In this video, we're going to look at some really simple and trivial examples on F sharp. And the references, at least for this video, you may want to bookmark this link of MSDN at Microsoft. So you can find some of the examples that I'm using in this video at that link. Okay, so first thing, let's just try to get an idea what functions are in F sharp. And before we really kind of look at it more formally, let's just step back here. And in math, if I would like to create a function of one variable, so let's have function f of x, function of one variable there, f of x, and this can be kind of easily interpreted by knowing that this f over here is the name of the function. X is basically the input, is the domain that gets fed into the function f there. And let's say this is really simple. All I'm doing is I'm going to take whatever this x is and I'm going to add 1 to it. Okay, so this is basically what a typical function of one variable, at least in math, would look like. If I would like to write a similar function, at least in F sharp here, and again, I'm just going to use a slightly different color and a slightly just to segregate my two styles of writing. So this is going to be in the F sharp side of things. You're going to see a lot of syntactically similarity in the way functions are actually even defined in F sharp here. So one way to write this, I could simply say over here, and I'm going to just explain the let binding a little bit later in my video. But the code, the actual code in F sharp would be let f of x equals to x plus 1. Okay, and this is basically what actual F sharp code here is. So let's just try this out. And I'm going to use again, I'm going to use over here the try F sharp. So that's the link if you would like to try this online and play within your browser. And so let's just go here and create a function f of x, which is basically a function of one variable. And I'm just going to run this code as it is, just to get an idea, just to get a feel for this, what is actually happening here. So so the first thing that we see here is when I write and compile and run this code, I see a few interesting things that have been inferred and interpreted by F sharp here. First thing that I see over here is that my function f over here is a function that has a certain type. It has a certain type that follows this notation there. It's a function that basically takes as an input an integer. It takes as an input an integer and out comes back as an output some another integer. So how did F sharp interpret f as a function that takes in an integer and gives you back an integer? It simply did that because I'm using in my code an integer 1 as part of my implementation, and it automatically inferred that this x that is being fed into my function f must also be an integer. Okay, so this is basically a type. This is a type of my function f. Likewise, I can also say that the type of this variable x there, the type of my variable x is basically an integer. Okay, so that's one way to think about types here. The type of this x over here happens to be an integer, and likewise the type of my function f is basically something that goes from an integer to an integer. So you can see that this explicit arrow notation there, basically is the start, or conveys to you that what I have now is basically a type that is associated with a function. And again, this is an input, and this is my output. Okay, so let's just call this function and just try this. Let's just try this out. So let's just say let g equals to f, and I'm going to call the function f by passing in the parameter 3. Okay, so again, in math, if I had a function f of x equals to x plus 1, and if we would like to call this function f with a parameter 3, the way you would do this in math is I'm just going to pass in 3, and wherever I see x's, I'm going to replace those x's with 3. So this basically becomes 3 plus 1. So what I have here is f of 3 equals to 4. Likewise, I'm just saying I'm calling my function f here in my f sharp, and I'm passing in the parameter 3, and whatever is the value of passing 3 into f, that value is going to be in G. And I already know that the functional type of f is basically a function that goes from an integer to an integer, and when I pass in 3, G is basically going to contain a value 4. So the type of G, the type of G is basically an integer, and the actual value that G contains is the value 4. Okay, so let's just try this out. Let's just compile and run this, and what I see over here is that G has a value of 4. Okay, and let's just look at a slightly kind of an advanced function from what we've been looking at so far, which is a function of one variable. So going back to my board here, let's just try to figure out what is the volume. What's the volume of a cylinder? So in math, if I would like to write a function of two variables now, so let's say I'm going to write a function v, and again, let me just be a little bit consistent with my color notation sets. So let's say I have a function v, and again, this is not yellow, it's actually orange. So let's go back and get my orange here. So I have a function v, which is basically standing for volume here, is a function of two variables, and the two variables here happens to be the radius and the length. And the way I define a volume, at least in for a cylinder, is basically simply the length times pi times radius square. Okay, this basically gives you the volume of the cylinder. To define a function of two variables in F sharp, the way we're going to do this is we're going to, again, coming back at the side of my board here, I'm going to say let, and again, let's just give us name here to our function. So let's say let v, and this is going to take my two parameters r and l, and this is going to be equal to. So again, just to understand what's happening here is this v over here is the name of my function, is the name of the function. The way in my previous example, f was the name of the function that took in one parameter x. What I have now is v as the name of the function that takes in as a parameter two parameters, and these two parameters here are radius and the length. And the way I'm going to define this as part of my implementation, and again, just to be a little bit clear here, just define some kind of a box here. Let's just define a box here that defines the implementation details of how I would compute the value of my cylinder. I'm going to say that this is going to be actually equal to, let's just go ahead and define a inner pi parameter. So let's just say let pi equals to 3.14, and I'm just going to, in this case, just return back whatever is length times pi times r times r. So again, very straightforward, nothing complicated in this implementation of a function of two variables. Let's just try this out in F sharp. So let's just go back. Let's just change this. So let's just say let v, and this is going to take in two parameters r and l. This is going to equal to let's have a definition for pi, which is 3.14, just using approximation there, and this is going to return back to you whatever is length times pi times r times r. Okay, and let's just first run this so you get an idea of what this function does. So this function is basically a function v there, and you can think about v as a function that that takes in r and an l. R and an l in this case happens to be a float, and gives you back as a return a float. We're going to look at function covering a little bit later, and but right now, this the very first float over here represents the radius. The second float over here represents the length, and the third float over here is the output value, which happens to be the actual volume that has been computed. And you can even see that interpretation right here, in F sharp, and you can see this mapping, which is completely equivalent. That this float over here happens to be with the variable r, where r is basically my radius, and likewise this L over here is of type float, and my L is right there in the definition of my function. Okay, so let's just try this out, and so let's just pass in some values. Let's say let g equals to, and I'm going to call my function v, and pass in, let's say, radius as 10 and my length as 20. And let's run this. And of course, I'm passing in integers there, so these should actually be floating values. So I'm just going to make that 10.0 and 20.0, and let's just run this again. And I see that that my G, which contains the actual volume, and it has been computed to 6280. Okay, so in the second video, we're going to play a little bit more with F sharp, and we're going to look at function composition, and we're going to look at some higher order functions.